Right, once again, let's talk about determinant and inverse of a matrix. Remember I said we have 7 concepts: naming matrices, addition and subtraction, scalar multiplication, equivalent matrices, general multiplication, addition, determinant, inverse, then special matrices. Let's talk about determinant first. Determinant of a matrix. Determinant of a matrix can be represented using straight bars like this. We can have matrix A in bars like this, or matrix B in bars like this. It means determinant. So what does that imply? Suppose you have a matrix A being A, B, C, D, and you are asked to find, which means the determinant of A. Determinant can only be calculated on 2 by 2 matrices, whereby 2 by 2 matrices have 2 diagonals. This one is called main diagonal or major diagonal, and then this one is called off diagonal. So when you are calculating determinant, you multiply numbers of major diagonal first, that is A times B. Then you subtract the product of numbers of diagonal B times C. So the formula for determinant is AB minus BC. Every time you are asked to find determinant, you multiply major diagonal, then the product, you subtract the product of diagonal. Let me illustrate it using numbers. You'll be given a matrix like this. Given that G equals 6 minus 2, 4, 1. Find. This symbol means determinant. So we are going to find the determinant of G. It's very simple. We multiply numbers of major diagonal. 6 times 1, subtracting off diagonal, minus 2 times 4. Take note, this minus will always lead you to a mistake if you are not maintaining accuracy. So you do better include brackets to handle that negative sign, because you need to multiply first. 6 times 1 is 6. In determinant, we always subtract. That's the subtraction. Then let's multiply these two. Minus 2 times 4 get minus 8. Now let's simplify. This will give us a positive 14. That's the determinant of a matrix. In examinations, they can do this trick. From the question like this, they say, given that G equals X minus 2, 4, 1, and also equals to 14, find value of X. Look at this interesting question. Now we included an unknown, a certain number minus 2, 4 in this one, but the determinant is known. The determinant is 14. So it's simple. You simply show the working. Working is equals to answer. They are saying the determinant is 14. So you simply prove that the determinant of this matrix is 14. So let's work out the determinant. X times 1 subtracting minus 2 times 4. The answer should be 14. We formulated an equation. Then we solve. X times 1 plus X minus 2 times 4, we get minus 8 is 14. So this is now positive. By grouping method, X equals to 14. This positive 8 will move and become negative 8. And finally, X is 14 minus 8, we get 6. Again, we bring back the number. So that's the determinant of a matrix. Let's take a look at the inverse of a matrix. inverse. Again, inverse can only be calculated on 2 by 2 matrices. Why? Because it has something to do with the determinant. Inverse can be represented by a negative power like this. You'll be given a matrix, then they do this to show the inverse. For instance, given that A equals to 4 minus 3 minus 2 and probably minus 1. And then the question is, find inverse of matrix A. To find the inverse, you need determinant first. So determinant equals to 4 times minus 1, subtracting minus 3 times minus 2. Determinant is calculated through multiplying major diagonal, then off diagonal. 4 times minus 1 get minus 4, minus 2 times minus 3 get positive 6. Then this will give us determinant negative 10. Alright, when you get the determinant, now we need to find the inverse. Inverse equals to 1 over determinant times the matrix. That's the formula. We find determinant first, they say 1 over determinant times the matrix. But this matrix, numbers of major diagonal, they exchange positions. Of diagonal, numbers will change, not exchange, they will change signs. If it was positive, it becomes negative, so negative positive. So now let me present the inverse. Inverse of A equals to, you say 1 over determinant, that's 1 over, the determinant is negative 10. Then we present the matrix. But this matrix now, major diagonal, they exchange. That is minus 1 and 4. They exchange the positions. Always in major diagonal, numbers exchange positions. In off diagonal, they maintain their positions, but the signs will change. This was negative 3, becomes positive 3. Negative 2, it becomes positive 2. If they were originally positive, they will become negative. Thus, inverse of a matrix. So it's simple, guys, to find the inverse of a matrix and the determinant of a matrix. So lastly and quickly, let's conclude the topic of matrices through looking at the 3 special types of matrices. We have 3 special matrices as we are going to talk about here. So we've got them, special matrices. Number 1, singular matrix. Number 2, identity matrix. Number 3, new matrix. These are the 3 types of matrices. Let's quickly go through the first one, singular matrix. Yes, a determinant, the same. A singular matrix is a matrix such that when you calculate its determinant, you get the answer 0. So in such a case, it's a special case, we call it a singular matrix. For instance, given that B equals to 4, 1, 8, and 2, then they say find the determinant of matrix B. Hence, what is special name is given to the matrix. What is special name given to B? Right, let's calculate the determinant of a matrix. So the determinant of matrix B is, remember, it's always major diagonal. 4 times 2, subtracting off diagonal, 8 times 1. And you get 4 times 2, 8, minus 8 times 1, 8. The answer is 0. If you get determinant 0, then special matrix, special name for B is a singular matrix. It's a special case. When you make a determinant of a matrix and you get negative, and you get 0, the matrix is called singular. In most exam questions, they examine on this concept, whereby they include letters like this. Check how they formulate the question. Suppose here we have this one. If I delete this one, then I say x plus 3. Then the question will be, given that B is and it is a singular matrix, or they can say yes, no inverse. It's another definition for singular matrix. Find value of x. Right. We are being told that matrix B is x plus 3. There's an unknown term A, but this matrix is singular. So the word singular there means that if you calculate determinant, you will get it 0. So they simply want you to prove that determinant is 0 and you find the value of x. You say working equals to answer. Determinant is 0, so let's show the working of determinant. You multiply this first. 2 multiplied by x plus 3, subtracting 8 multiplied by 1, the answer will be 0. Then you solve the equation. 2 times x, 2x, 2 times 3, 6, minus 8 is equals to 0. If you solve, group this equation, you get to know the value of x. 2x equals to, if you move this 8, it will become positive 8, 6 will become negative 6. So now 2x is in 8 minus 6, 2. You divide by 2 both sides, and x is in 1. That's singular matrix. Every time you calculate determinant, you get 0. Then the other matrix is called an identity matrix. Identity matrix identity matrix I. This one now, an identity matrix is 1, 0, 0, 1. Starts with a 1 and ends with a 1. There are two things which are special about this matrix. Always, every time you see an identity matrix, you must know that it is a 1-unit matrix. If you multiply by an identity matrix, you are just as good as someone who is multiplying numbers by 1. Like 1 times 8 is 8, 1 times 10 is 10, 1 times 30 is 30. If you multiply a number by 1, the number will not change. So the same applies here. If you multiply a matrix by identity, there will be no any change. So in your notes, you can add that multiplication by an identity matrix will bring no change to the other matrix. That is, if we have 1, 0, 0, 1 identity matrix multiplied by 2, 3, 4, 1, there will be no change. This matrix is the answer. If you multiply any matrix by an identity, the matrix will not change. The answer will be still 2, 3, 4, 1. Let me quickly prove it. We are handling general multiplication. 1 times 2 is 2, plus 0 times 4 is 0. Then 1 times 3 is 3, plus 0 times 1, 0. 0 times 2 is 0, plus 1 times 4, 4. 0 times 3 is 0, plus 1 times 1, 1. So now 2 plus 1 is 2, is 3 plus 0 is 3, 0 plus 4 is 4. If you multiply any matrix by an identity matrix, there will be no any change. Then one more interesting thing is, this matrix is a result of multiplying a matrix by its inverse. If you take matrix A, then you calculate its inverse. After getting the inverse, if you multiply the two, the answer will be an identity matrix. So every time they tell you that we multiplied two matrices and the answer was 1, 0, 0, 1, it means the matrices multiplied were sharing a certain relationship whereby one is a matrix and the other is the inverse. The last one, new matrix. New means 0. So a new matrix has zeros only. A new matrix is a matrix with zeros only, like this. Nothing much special about 0. You know, if you multiply a number by 0, it will give you 0. 0 times 10, 0. 0 times 40, 0. 0 times 100, 0. So if you multiply any matrix by a new matrix, like this, the answer is 1, the answer will be 0. Multiplication by a new matrix always give a new matrix. So now you check in topic of collection, you attempt to pass the exam questions based on the topic matrices. It's important to understand this topic because we'll be using it in so many topics to come, transformation and so on. They are basing on the topic matrices. Signing out.